Machine learning questions that phone interviewers really care about. What is the role of the discriminator in a generative adversarial network (GAN)? Answer: the discriminator is a neural network that tries to determine the difference between real images and fake images produced by the generator. Its ultimate goal is to learn to identify real and fake images, which helps the generator to produce images that are closer in appearance to real images. The discriminator does this by receiving a batch of images, both real and fake, and outputting a probability that each image is real. This process helps the generator to improve its performance by learning from the discriminator's feedback. What is an autoencoder and how does it work? Answer: an autoencoder is a type of neural network that has 3 layers, where the number of input neurons is equal to the number of output neurons. Its main goal is to reconstruct the input data by compressing it into a lower-dimensional representation, called the latent space, and then reconstructing the output from this representation. In other words, it takes an image as input, compresses it into a smaller representation, and then tries to reconstruct the original image from this representation. This process helps to reduce the dimensionality of the input data, making it easier to analyze and to understand. The autoencoder works by minimizing the difference between the original input and the reconstructed output, which is achieved through backpropagation and optimization techniques. What is bagging and boosting, and how do they differ in their approach to training multiple models? Answer: bagging and boosting are ensemble techniques used to improve the accuracy of machine learning models. Bagging, short for bootstrap aggregating, involves training multiple models on random subsets of the same dataset and then combining their predictions. This approach reduces the variance of the model and can improve its performance on unseen data. Boosting, on the other hand, involves training multiple models sequentially, with each model focusing on the errors made by the previous model. This approach can improve the accuracy of the model by correcting its mistakes and reducing its bias. The key difference between bagging and boosting is that bagging uses random subsets of the data, while boosting uses the errors of the previous model to guide the training of the next model. This difference in approach can lead to different strengths and weaknesses in the resulting models. What is the significance of using the Fourier transform in deep learning tasks? Answer: the Fourier transform is significant in deep learning tasks because it helps to efficiently analyze, process, and manage large datasets, which is crucial for tasks that involve processing multiple signals in real time. This allows for the extraction of meaningful features and patterns from the data, enabling the development of more accurate and efficient deep learning models. Additionally, the Fourier transform can be used to generate real-time array data, making it a valuable tool for applications such as signal processing, image and speech recognition, and natural language processing. What is transfer learning, and can you give some examples of commonly used transfer learning models? Answer: transfer learning is a process where a pre-trained model is used to solve a new but similar machine learning problem without having to train it from scratch. This is done by taking critical parts of the pre-trained model and applying them to the new problem. Some examples of commonly used transfer learning models include VGG-16, BERT, GTP-3, Inception v3, and Exception. These models have already been trained on large datasets and have learned general features that can be applied to new problems, making it easier and more efficient to train a new model. What is the difference between same and valid padding in TensorFlow? Answer: in TensorFlow, same padding ensures that the filter is applied to all elements of the input by adding padding to the input image, resulting in an output size that is the same as the input size when the stride is 1. On the other hand, valid padding implies no padding in the input image, and the filter window stays inside the input image, assuming that all dimensions are valid. This means that the filter will not be applied to elements outside the input image. The choice between same and valid padding depends on the specific requirements of the convolutional neural network CNN being implemented. What are some of the common applications of autoencoders in deep learning? Answer: autoencoders are a type of neural network that can be used for various tasks in deep learning. Some of the common applications of autoencoders include feature extraction, dimensionality reduction, and noise removal. Feature extraction involves using the autoencoder to extract relevant features from the input data, which can be useful for tasks such as image classification. Dimensionality reduction involves using the autoencoder to reduce the number of features in the input data, which can be useful for tasks such as data visualization. Noise removal involves using the autoencoder to remove unwanted noise from the input data, which can be useful for tasks such as image denoising. Additionally, autoencoders can also be used to generate new data that is similar to the training data, which can be useful for tasks such as data augmentation. Overall, autoencoders are a powerful tool in deep learning that can be used for a wide range of applications. What is the swish function and how is it different from ReLU? Answer: the swish function is an activation function proposed by Google as an alternative to the ReLU rectified linear unit activation function. It is represented as f x equals x asterisk sigmoid x, which is a combination of the input value x and the sigmoid function. This function works better than ReLU for deeper models as it allows for a smoother and more continuous gradient flow. The derivative of swish can be written as y equals y plus sigmoid x asterisk 1 y, which is used to calculate the gradient during backpropagation. Overall, swish is a more flexible and effective activation function than ReLU, making it a popular choice for deep learning models. What are the reasons for mini-batch gradient being so useful in machine learning? Answer: mini-batch gradient is useful because it is highly efficient compared to stochastic gradient descent, allowing it to attain generalization by finding the flat minima. Additionally, it helps avoid local minima, enabling gradient approximation for the whole dataset. This makes it a popular choice in machine learning algorithms. What is leaky ReLU, and how does it differ from the traditional ReLU activation function? Answer: leaky ReLU is an advanced version of the ReLU rectified linear unit activation function. In traditional ReLU, the gradient is 0 when all the input values are less than 0, which means the neurons are deactivated. To overcome this limitation, leaky ReLU introduces a small slope for negative values, unlike traditional ReLU, which has a flat slope. This allows the neurons to learn from the negative values as well, making it a more effective activation function for deep neural networks. What is data augmentation in deep learning, and what are some common techniques used to augment data? Answer: data augmentation is a process in deep learning when new data is created by enhancing the size and quality of training datasets to improve model performance. This is done to increase the diversity and robustness of the training data, which helps the model learn more effectively. Common techniques used for data augmentation include numerical data augmentation, image augmentation, GAN-based augmentation, and text augmentation. These techniques involve transforming the original data in various ways, such as rotating, flipping, or adding noise to create new and diverse examples that can help the model generalize better to unseen data. By augmenting the data, we can improve the accuracy, robustness, and interpretability of the deep learning models. What is the ADAM optimization algorithm, and how does it differ from traditional stochastic gradient descent? Answer: the ADAM optimization algorithm is an extension to the stochastic gradient descent, designed to handle complex problems with large amounts of data or parameters. It combines two gradient descent methodologies, momentum and root mean square propagation, to optimize the learning process. Unlike traditional stochastic gradient descent, ADAM optimization algorithm is more efficient and requires less memory, making it a popular choice for large-scale machine learning tasks. By adapting the learning rate for each parameter based on the magnitude of the gradient, ADAM optimization algorithm can escape local minima and converge faster to the optimal solution. This makes it a powerful tool for training deep neural networks and other complex models. Why is a convolutional neural network preferred over a dense neural network for an image classification task? Answer: a convolutional neural network CNN is preferred over a dense neural network for image classification tasks because it has a smaller number of parameters, making it less likely to overfit. Additionally, CNN allow for the visualization of filter weights, providing a better understanding of what the network has learned. Furthermore, CNN train models in a hierarchical manner, breaking down complex patterns into simpler ones, making it more effective for image classification tasks. Which strategy does not prevent a model from overfitting to the training data? Answer: regularization, such as dropout or lone/alt, where regularization does not prevent a model from overfitting to the training data. Regularization is a technique used to reduce the complexity of the model by adding a penalty term to the loss function, but it does not prevent the model from overfitting. Overfitting can still occur if the model is too complex or if the training data is noisy. To prevent overfitting, other strategies such as early stopping, data augmentation, or using a simpler model architecture may be more effective. What is dropout in the context of neural networks, and how does it help in preventing overfitting? Answer: dropout is a regularization technique used in neural networks to prevent overfitting. It works by randomly dropping out a fraction of the neurons during training, which helps to prevent the network from relying too heavily on a specific set of neurons. This forces the remaining neurons to learn to compensate for the missing neurons, making the network more robust and less prone to overfitting. By randomly dropping out neurons, dropout helps to reduce the complexity of the network and prevent it from memorizing the training data, which can lead to poor performance on new, unseen data. Dropout is a widely used technique in deep learning and has been shown to be effective in improving the generalization performance of neural networks. What is pooling in the context of neural networks? Asset pooling is a technique used in neural networks to reduce the spatial dimensions of the input data while retaining important features. It is a type of downsampling operation that helps to reduce the number of parameters and the amount of computation required, making the network more efficient and less prone to overfitting. Pooling works by taking a small window of the input data and moving it across the entire input, applying a function to the values within the window, and then moving on to the next window. The output of the pooling operation is a smaller representation of the input data, which is then fed into the next layer of the network. Common types of pooling include max pooling and average pooling. Max pooling selects the maximum value within the window, while average pooling calculates the average value. Pooling is an important component of many neural network architectures, including convolutional neural networks CNN and recurrent neural networks RNN. What is data augmentation, and why is it used in machine learning? Answer: data augmentation is a technique used in machine learning to artificially increase the size of a training dataset by creating new examples from existing ones. This is done to help the model generalize better to new and seen data. By applying random transformations, such as rotation, flipping, or color jittering, to the existing data, we can create new, diverse examples that are similar to the original data. This helps the model learn to recognize patterns and features that are robust to small changes in the data, making it more accurate and less prone to overfitting. In other words, data augmentation helps the model learn to generalize better by exposing it to a wider range of data variations. What is early stopping in the context of convolutional neural network CNN? Answer: early stopping is a technique used in CNN to prevent overfitting by stopping the training process when the model's performance on the validation set starts to degrade. This is achieved by monitoring the model's performance on the validation set at each epoch and stopping the training when the performance on the validation set no longer improves. This helps to prevent the model from overfitting to the training data and improves its generalization ability. Note: the original question early stopping is quite vague and does not provide enough context. Therefore, I have generated a more specific question that is relevant to the context of CNN. The answer provides a clear and detailed explanation of early stopping in the context of CNN. Explain 2 ways to deal with the vanishing gradient problem in a deep neural network. Answer: the vanishing gradient problem occurs when the gradient of the loss function with respect to the weights of a deep neural network become very small, making it difficult for the network to learn. 2 ways to deal with this problem are: 1. Using the ReLU rectified linear unit activation function instead of the sigmoid function. This is because ReLU does not introduce any vanishing gradients, as it only outputs 0 or the input value, whereas sigmoid outputs a value between 0 and 1, which can lead to vanishing gradients. 2. Initializing neural networks using Xavier initialization, which is specifically designed to work with 10 activation. Xavier initialization helps to reduce the vanishing gradient problem by initializing the weights randomly, but in a way that the magnitude of the gradients is preserved. This allows the network to learn more effectively. By using these two methods, the vanishing gradient problem can be mitigated, allowing the deep neural network to learn more effectively. Why is a deep neural network considered more efficient than a shallow neural network? Answer: a deep neural network is more efficient because it learns something new in every layer, whereas a shallow neural network has only one hidden layer. This allows the deep neural network to create a deeper representation and computation capability, making it more powerful in approximating the values of a function. In contrast, a shallow neural network's limited representation and computation capability make it less efficient. What is the need to add randomness in a weight initialization process? Answer: adding randomness to the weight initialization process is crucial because if the weights are set to 0, every neuron at each layer will produce the same result and the same gradient value during backpropagation, making it impossible for the neural network to learn the function due to the lack of asymmetry between the neurons. This randomness ensures that the neural network can learn and differentiate between neurons, allowing it to learn the function correctly. How can you train hyperparameters in a neural network? Answer: hyperparameters in a neural network can be trained using 4 components: batch size, epochs, momentum, and learning rate. Batch size refers to the size of the input data, epochs denote the number of times the training data is visible to the network, momentum helps in determining the next steps, and learning rate represents the time required for the network to update its parameters and learn. These hyperparameters can be tuned to optimize the performance of the neural network. By adjusting these hyperparameters, you can control the learning process and achieve better results. For instance, a higher learning rate can lead to faster convergence, but may also cause the network to overshoot the optimal solution. On the other hand, a lower learning rate can lead to slower convergence, but may provide a more stable solution. By experimenting with different combinations of hyperparameters, you can find the optimal settings for your specific problem. What is the main function of an encoder in data processing? Answer: an encoder is a data processing component that compresses the input data into a smaller representation, typically referred to as an encoded representation. This compression reduces the size of the input data, making it more efficient for storage or transmission. The encoder's primary goal is to shrink the original data while preserving its essential information, allowing for faster and more convenient processing. What is a latent space representation, also known as a bottleneck or code, and what is its purpose in machine learning? Answer: a latent space representation, also known as a bottleneck or code, is a compact summary of the input data that contains the most important features. It is a low-dimensional representation of the original input data, which is used to reduce the dimensionality of the data while preserving the most relevant information. The purpose of a latent space representation is to enable the model to focus on the most important features of the input data, making it easier to learn and generalize. This is particularly useful in situations where the input data is high-dimensional, noisy, or complex, as it allows the model to extract the essential features and ignore the irrelevant ones. By using a latent space representation, the model can learn more efficiently and accurately and make better predictions. What is the role of the decoder in an autoencoder, and how does it compare the input and output images? Answer: the decoder in an autoencoder decompresses the knowledge representation and reconstructs the data back from its encoded form. This means it takes the compressed data from the encoder and converts it back into the original input data. The decoder then compares the reconstructed output with the original input image using a loss function, ensuring that the dimensionality of the input and output is the same. This process allows the autoencoder to learn and improve its ability to compress and reconstruct data. The middle part of the autoencoder, which includes the encoder and decoder, can be modified and experimented with to achieve better results. What are the similarities between transformers and Big Bird, and how do they relate to text summarization and generation? Answer: transformers and Big Bird are both neural network architectures that utilize autoencoders, a type of component that compresses and reconstructs input data. In the context of natural language processing, they are used for text summarization and generation tasks. Specifically, they are designed to learn the patterns and relationships between words and phrases in a text, and then generate a condensed version of the text or create new text based on those patterns. The key similarity between the two is their ability to learn and represent complex patterns in text data, allowing them to generate high-quality summaries in text. What is image compression and how does it work? Answer: image compression is a technique used to reduce the size of an image file while maintaining its quality. It works by identifying and removing redundant or unnecessary data from the image, such as duplicate pixels or patterns. This is achieved through various algorithms and techniques, including lossless and lossy compression methods. Lossless compression methods, such as run-length encoding (RLE) and Huffman coding, remove redundant data without losing any information, while lossy compression methods, such as JPEG, reduce the image quality by discarding some of the data. The compressed image can then be stored or transmitted, taking up less space and reducing the time it takes to transfer. This makes image compression an essential tool in various fields, including digital photography, graphic design, and web development. What is an activation function, and discuss the use of an activation function in a neural network. Explain 3 different types of activation functions. Answer: an activation function is a mathematical function used in a neural network to introduce nonlinearity between the input and output of a neuron. It decides whether a neuron should be activated or not, allowing the network to capture more complex features and model nonlinear variations. There are several types of activation functions, including the sigmoid function, ReLU rectified linear unit, and leaky ReLU. The sigmoid function is commonly used for classification problems, while ReLU is faster and more commonly used due to its simplicity. Leaky ReLU solves the vanishing gradient problem by returning a value for negative inputs. Softmax is often used as the activation function in the output layer for classification problems, returning a set of probabilities that add up to 1. Each type of activation function has its own strengths and weaknesses, and the choice of activation function depends on the specific problem being solved. What can you do to reduce overfitting in a deep neural network after training? When you notice that it is strongly overfitting the training set and the performance on the test set is poor. Answer: to reduce overfitting in a deep neural network, you can make changes in 3 places/stages: the input data to the network architecture, and the training process. This can include techniques such as data augmentation, regularization, and early stopping, which can help to prevent the model from overfitting to the training data and improve its generalization performance on unseen data. What are the essential checks to perform on the input data to the network before training? Answer: before training a network, it is crucial to check if all the features are available and reliable. Additionally, verify that the training sample distribution is the same as the validation and test set distribution. This ensures the model is not biased towards patterns it has not seen before. Furthermore, inspect the dataset for train/valid data contamination and leakage, and ensure the dataset size is sufficient. If not, consider data augmentation to increase the dataset size. Finally, verify that the dataset is balanced to prevent biased predictions. By performing these checks, you can ensure your network is well prepared for training and will produce accurate results. Question: what are the potential issues that may arise if the training sample distribution is different from the validation and test set distribution? Can fully connected layers be replaced with convolutional and pooling layers in the network architecture to reduce the risk of overfitting? Answer: yes, fully connected layers can be replaced with convolutional and pooling layers to reduce the risk of overfitting. This is because convolutional and pooling layers are designed to extract features from images in a hierarchical manner, which can help to reduce the complexity of the model and prevent it from overfitting into the training data. Additionally, convolutional and pooling layers are often used in convolutional neural networks (CNN), which are known for their ability to generalize well to new data. By using convolutional and pooling layers, the model can learn to extract features that are relevant to the task at hand, rather than memorizing the training data. This can help to improve the model's performance on unseen data and reduce the risk of overfitting. Why is it necessary to use batch normalization in deep neural networks? Answer: batch normalization is necessary in deep neural networks because it helps to standardize the inputs to a layer for each mini-batch, which can combat the issues of vanishing gradients or exploding gradients that occur when the distribution of the data differs for every batch size. This technique helps to stabilize the training process and improve the performance of the network. What is robust training of the deeper layers of a neural network, and how does it improve the model's performance? Answer: robust training of the deeper layers of a neural network refers to the process of training the deeper layers of the network in a way that makes the model more resistant to errors and outliers. This is achieved by using techniques such as regularization, data augmentation, and adversarial training, which help to reduce the model's reliance on specific features or patterns in the data. By training the deeper layers more robustly, the model becomes more accurate and reliable, and is better able to generalize the new and unseen data. This is particularly important in deep learning applications where the model is expected to make predictions in real-world scenarios where the data may be noisy, corrupted, or incomplete. What is a better covariate shift-proof neural network architecture, and how can it be designed to handle the covariate shift problem in machine learning? Answer: a better covariate shift-proof neural network architecture can be designed by incorporating techniques that adapt to changes in the input distribution. One approach is to use a combination of domain adaptation and transfer learning. This can be achieved by using a neural network with a shared encoder and multiple decoders, one for each domain. The shared encoder learns to extract features that are robust to the covariate shift, while the decoders learn to adapt to the specific distribution of each domain. Additionally, using techniques such as data augmentation, regularization, and early stopping can also help to improve the robustness of the model to covariate shift. By designing the architecture in this way, the neural network can learn to generalize well to new and unseen data and handle a covariate shift problem effectively. What has a slight regularization effect on the distribution of a random variable? Answer: a slight regularization effect on the distribution of a random variable is observed when a random variable is approximated using a normal distribution, which tends to reduce the extreme values and make the distribution more symmetric and bell-shaped. This is because the normal distribution has a finite range and is more concentrated around the mean, whereas the original distribution may have a longer tail and be more spread out. As a result, the normal distribution provides a more stable and predictable representation of the random variable, which can be useful in many applications. What are centered and control values of activation in the context of neurons? Answer: in the context of neurons, centered and control values of activation refer to the process by which the strength of neural connections is adjusted based on the frequency and timing of neural activity. This process helps to refine the communication between neurons, allowing them to transmit and receive information more efficiently. Centered values of activation refer to the optimal strength of neural connections, while control values of activation refer to the ability of neurons to regulate the strength of their connections in response to changing environmental conditions or internal states. This process is crucial for learning and memory, as it allows neurons to adapt and refine their connections in response to experience. What is the purpose of normalization in deep neural networks, specifically in the context of preventing exploding/vanishing gradients? Answer: normalization in deep neural networks helps to prevent exploding/vanishing gradients by scaling the input values to a fixed range, typically between -1 and 1. This is done to stabilize the gradients during backpropagation, preventing them from growing or shrinking exponentially, which can cause the model to diverge or converge too slowly. By normalizing the inputs, the gradients are kept within a reasonable range, allowing the model to learn more efficiently and accurately. This is particularly important in deep networks where the gradients can easily become too large or too small, making it difficult for the model to learn. Normalization techniques such as batch normalization and layer normalization are commonly used to achieve this. How can I identify if my model is suffering from the problem of exploding gradients during training? Answer: exploding gradients occur when the gradient updates to the weights and biases in a neural network become excessively large, causing the weights to overflow or become not-end. Some subtle signs that you may be experiencing this issue during training include: rest of the answer remains the same. Why is the model unable to get traction on the training data, resulting in poor loss? Answer: the model is unable to get traction on the training data because it is not able to learn and improve from the data provided. This can happen when the model is not well suited for the task, the data is noisy or imbalanced, or the model is not trained properly. As a result, the model's loss function is not decreasing, indicating poor performance. To resolve this issue, the model can be retrained with a different architecture, data preprocessing, or hyperparameter tuning. Additionally, data augmentation, regularization, or ensemble methods can be used to improve the model's performance. What is causing the model to be unstable, resulting in large changes and loss from update to update? Answer: the model is unstable because it is experiencing large changes and loss from update to update, which is likely due to the model's weights being updated too aggressively, causing the model to oscillate between different solutions. This can happen when the learning rate is too high or when the model is not regularized properly. As a result, the model is not converging to a stable solution, and its performance is fluctuating wildly. Why does the model loss go to naught and during training? Answer: the model loss goes to naught and during training because of exploding gradients. This occurs when the gradients of the model's parameters become too large, causing the model's weights to update excessively, leading to a loss that is not a number, not n. This can happen when a model is not properly regularized or when the learning rate is too high. To resolve this issue, you can try reducing the learning rate using gradient clipping or adding regularization techniques to the model. Why do the model weights quickly become very large during training? Answer: during training, the model weights are updated based on the error between the predicted output and the actual output. As the model learns, the weights are adjusted to minimize this error. However, this process can lead to an increase in the magnitude of the weights, causing them to become very large. This is because the updates are based on the gradient of the loss function with respect to the weights, and the gradient can become very large as the model learns. As a result, the weights can grow exponentially, leading to a phenomenon known as exploding gradients. To mitigate this issue, techniques such as gradient clipping and normalization are often used to stabilize the training process. Why do the model weights go to naught and values during training? Answer: naught and not a number of values occur when the model weights are divided by 0 or when there is a division by 0 in the calculation of the weights. This can happen when the input data is not properly normalized or when there is a bug in the code. When this happens, the model is unable to learn from the data and the weights become naught n. This can be prevented by checking for naught n values in the input data and normalizing it properly. Additionally, using techniques such as dropout and regularization can also help to prevent naught n values from occurring. What are some common hyperparameters used in training a neural network, and how do they affect the model's performance? Answer: hyperparameters are settings that are adjusted before training a neural network, such as learning rate, batch size, number of hidden layers, and number of neurons in each layer. These hyperparameters affect the model's performance by controlling how quickly the model learns, how much data is used for each update, and how complex the model is. For example, a high learning rate can cause the model to jump to a poor local minimum, while a low learning rate can cause the model to converge slowly. Similarly, a large batch size can cause the model to ignore some of the data, while a small batch size can cause the model to overfit to the training data. By adjusting these hyperparameters, the model's performance can be improved. What is the relationship between the number of nodes and the number of inputs in each layer of a neural network? Answer: the number of nodes in a layer of a neural network is equal to the number of inputs in that layer. This means that if a layer has a certain number of inputs, it will also have the same number of nodes. This relationship is crucial in designing and building neural networks, as it determines the capacity of each layer to process and transform the input data. What is batch normalization, and how does it help in the process of deep learning? Answer: batch normalization is a technique used in deep learning to normalize or standardize the inputs in a layer. This helps to stabilize the learning process, reduce the effect of internal covariate shift, and improve the performance of the model. By normalizing the inputs, Batch normalization helps to reduce the impact of changes in the distribution of the input data which can occur during training. This makes it easier for the model to learn and generalize the new data. In simple terms, batch normalization helps to ensure that the model is learning from a consistent and stable set of inputs, which can lead to better performance and more accurate predictions. What is the learning rate, and how does it affect the training process of a neural network? Answer: the learning rate is a parameter that determines the rate at which the weights of a neural network are updated during the training process. It is a critical hyperparameter that controls how quickly the model learns from the data. A higher learning rate can cause the model to jump to a suboptimal solution, while a low learning rate can lead to slow convergence. A well-chosen learning rate can help the model converge to a good solution efficiently. In general, a learning rate that is too high can lead to oscillations or overshooting, while a learning rate that is too low can lead to slow convergence or underfitting. The ideal learning rate depends on the specific problem, the model architecture, and the optimization algorithm used. A common approach is to start with a high learning rate and gradually decrease it as the training progresses to avoid overshooting. What is the dropout rate, and how is it used in neural networks? Answer: the dropout rate is a percentage of nodes neurons that are randomly dropped or ignored during the forward pass in a neural network. This technique is used to prevent overfitting, which occurs when a model becomes too specialized to the training data and fails to generalize well to new unseen data. By randomly dropping nodes, the model is forced to learn to represent the data in a more robust and distributed way, reducing its reliance on any single node or feature. This helps to improve the model's generalization performance and prevent overfitting. The dropout rate is typically set between 0.2 and 0.5, and the nodes are dropped randomly during each training iteration. What is the purpose of the kernel matrix in the given context? Answer: the kernel matrix is used to perform a dot product operation with an image array. This operation is likely used in a machine learning or computer vision application, where the dot product is used to compute the similarity or correlation between the image array and the kernel matrix. The result of the dot product can be used to classify the image, detect objects, or perform other tasks. The use of a kernel matrix allows for the computation of complex patterns and relationships between the image data and the kernel matrix, enabling more accurate and robust results. What is the purpose of an activation function in a neural network? Answer: an activation function defines how the weighted sum of inputs is transformed into outputs in a neural network. This means it determines the output of each neuron based on the sum of its inputs and their corresponding weights. Different activation functions, such as tan, sigmoid, softmax, ReLU, etc., can be used to introduce nonlinearity into the network, enabling it to learn and represent more complex relationships between inputs and outputs. In other words, the activation function helps the network to learn and make decisions by introducing nonlinear relationships between the inputs and outputs.